the technical subject matter, that's link analysis. Let me is on link analysis. Okay, the broad question that we're going to be discussing is how to organize the web. Okay, so this is a picture that's from around 1996. Okay, where if you wanted to learn something about, let's say, science, you would go to yahoo.com. And they would have what's called a human curated web directory. So they would basically go through the entire internet. The internet wasn't so large back then. And they would go ahead and say, all right, so in the field of science, you know, you have various subjects. Engineering is one of them. And you have various other subjects. In the field of education, you have various universities. You have K-12. K-12 means kindergarten to 12th standard, and so on. And so they would basically create directories. And then when you click on, so you have categories like education, you have subcategories like universities and K-12. You go to click on one of those subcategories like universities, and then you could go and find many of the universities listed, and then you can go to their website. So the web, the entire internet was organized by some human curated directories, such as what you're seeing over here. The problem was that this approach did not scale because the web was growing too quickly. There was just too much information that was there, and too much information that was being added every day. So if you do a Google search today for some information that was added yesterday to the web, you might quite likely find that information because now things are much more automated rather than human curated. So instead of creating human curated web directories, the approach was, so this thing, by the way, was in 1996. By the way, there's someone whose cough I just heard. If you could please mute yourself, that would be great. Just give me 1 second to see who that might be. Okay, just actually, okay, fine. I think it's Ashish Gumparti. Could you please mute yourself? Thank you, Ashish, great. Okay, it's just that, you know, if there's some background noise, others would find it a bit difficult. Okay, thank you. I wish it was very interactive where people could just ask questions, you know, using their audio, but somehow we don't have that yet. Okay, so the second approach to do it for searching on the internet is to do information retrieval, where you find relevant documents in a small trusted set. So what a search engine could do is just go to the internet and crawl. We'll talk about this briefly in a while. But it could crawl and download all the web pages. So it goes to one particular web page and it follows all the hyperlinks which are there and goes to those new web pages. Then it goes, from there it goes to other web pages. So it starts out with an initial list of many URLs, many web pages, addresses. And then from there it goes out and crawls the rest of the web and sees what all it can get. Now it has a set of documents. And whenever you do a search query for some particular word or phrase, it would search those documents and then return the documents which contained your words. So the problem is that there are many people who exploit the situation and create documents which contain certain words, even though the documents are not about, you know, those particular words. So you can go ahead and do all sorts of things so that this particular method doesn't really work. So the early search engines, they crawled the web and listed all the words in something called an inverted index. So now when you have a document, okay, a web page, it can, the document points to all the words which are in that document. That's how you normally, when you store many documents, each document is mapped to a sequence of words. And an index, as you know from the back of a book, will have an index where the words will map to the page numbers in the book where the word is found, right? So that's called an index. And An inverted index is actually just an index. The word inverted is actually redundant. Okay, basically it's an inverted thing. So instead of having a document being mapped to a sequence of words, what you do is you create a dictionary of all the words, and each word in your inverted index is mapped to a list of all the documents that contain that word. Okay, so each word is going to be mapped to a list of all the URLs of web pages which contain that particular word. That's an inverted index. And then when you go ahead and give a search query and you type some words into the search engine, it would immediately have a list of all the documents which contain that word, or those few words. It can go ahead and find all the documents that contain all the 3 words that you entered, for example. And if if in particular, it can also store which words appear in the title or the header of the web page. That can be given a higher priority than if the word appears in the text or body of the web page. And so those pages would be ranked higher. And so this can be done. The problem is that there are many techniques for fooling search engines. So you can certainly go ahead and display very important words in a web page many times in the same color as the background. So the search engine, when it crawls the web and creates the inverted index, your document, if you're a website owner, you could do something like this, and your document then would end up showing up as one of the very relevant web pages, but really you haven't listed it in your document. And so people can fool, and then there's other ways as well in which people can fool search engines. And Google's first innovation, it's still used in many modern, in pretty much all modern search engines, is a way to figure out which web pages are important by looking at the link structure of the web graph. So there's a particular algorithm that Google developed, which was developed in 1998 by the Google founders, Brin and Page. And there's a mathematical idea behind it where you could think of, we will get to that in a couple of lectures, but you basically simulate a random web surfer. You assume the web surfer started at a particular random page in the internet and uniformly at random chose one of the many hyperlinks which are on that page as the next web page. So you have a sequence of web pages. You're jumping from one web page to another. And so there's this random web surfer interpretation of the Pagerank algorithm. And this algorithm will output the score of each page. And the score of a page will depend not only on what words are in that page, but also the content of the in neighbors and the out neighbors. I should really say who are the in neighbors and who are the out neighbors. Okay, so let me be sort of there. I would say content also is true. When a web page A points to a web page B, the hyperlink on web page A, when you click on it, what you're clicking on is called the anchor text. Okay, that anchor text is part of web page A, but Google says, hey, it also gives you information about web page B. So I'm going to actually also make that a part of the information about web page B. So the content of what are called the in neighbors of web page B are also used to talk, to infer what web page B is about. If you don't know what in neighbors is, don't worry about it. We'll get to it very soon. And Google's algorithm works very well empirically, and we will see very clearly. I'll give you the pseudocode as well as the Python program for how the PageRank algorithm is computed. It's just a few lines.